This will be the third out of our 3 videos about the properties of exponents. This video will focus mainly on the power property, where if you have x to the a all to the b power, then you get to multiply those powers. Typically it's called the power of a power, and then you can multiply them. Here's a basic example to begin. You have x to the third power all to the third power again. So if we write this out, that's really like we're saying that we have x to the third times x to the third times another x to the third. All right, so there's 3 of those that are all being multiplied by each other, which is really important. So you could go even further and say that you have x times x, which is the x to the third, times another x times x times x, times a final x times x times x. And so you can see that you have 9 x's, which is really just x to the 9th. Students tend to be tricked at the beginning to say that these 3's should just be added to each other, but really they need to be multiplied. And using our property that we see, we have x to the third is really x to the 3 times 3, which is how you end up with the x to the 9th. So as you look at a second example, we have x to the 9th squared, which could be thought of as x to the 9th times x to the 9th. Now, I'm obviously not going to write out all of those x's like I did in the previous example, but what you do see is that you could also use your property of multiplication, where you could do 9 plus 9, and that's also going to get you to your x to the 18th, which, using our power property, is x to the 9 times 2. So that's how you multiply your powers. A third example would be x to the negative 4 to the third, which would be x to the negative 12th, because that is x to the negative 4 times 3. But this would be the final answer of that product. However, that's not how we want to leave our powers, because we don't want to leave them with negative exponents. So a previous video talked about how you can move that x to the negative 12th down to the denominator if you would imagine this being over 1. And so your final answer here would be 1 over x to the 12th. Now this next example is an extremely important example for us to think about, because you have 5x squared all to the third. So if I write this out as I've written out others, that'd be 5x squared times another 5x squared times a third 5x squared. And what you end up with is not only do you have to do the power of a power with the 2 and the 3, right? So you multiply those because you have 2, 4, 6 of them. So that's going to be x to the 6th for the x part. But what a lot of students make mistakes with, and it's a very common mistake, is what happens with this 5. Because we don't do 5 times 3, because this 5 is not an exponent. In actuality, the exponent here is a 1, right? Because that's 5 to the first. So that's where you're multiplying the power of a power. So it's really 3 times 1, which you could write as 5 to the third. If you wanted to see how this worked with our property, you would write this as 5 to the 1 times 3 times x to the 2 times 3, which is how you end up with that 5 to the third here. Again, it's a place many students make mistakes because they try to do 5 times 3 and write 15 here, but it's really 5 to the third, which you would want to finish as 125 x to the 6th. And if we finish with our final example here, remember that this power of 3 is really a 1, right? So 3 is not the power, 3 is the base, the exponent is 1. This power of 4 is going to use this power property, where you're going to multiply the 11 times 4, the 9 times 4, and the 1 times 4. So what this is going to turn into, using our property, is 3 to the 1 times 4 times x to the 9 times 4 and y to the 11 times 4. So your final answer would be 3 to the 4th, x to the 36th, and y to the 44th. And we want to write 3 to the 4th as 81, x to the 36th, y to the 44th still for your final answer. So power of power you multiply. That part most students get pretty quickly. Be really careful when you have a multiple in front, because this 5 and this 3 are not exponents, they are the base. You need to do the 4th power of that base.